Okay, in this physics problem we're gonna work on calculating forces. Here we have a ball that's hanging from the ceiling with two wires. One is from the ceiling and then it's pulled sideways and tied to the vertical wall, and then there's a knot in the middle, and then this thing is hanging on it. This could be a ball, a store sign, or a chandelier, you name it. And they want us to find the tension in the this cord and this cord, FA and FB. Okay, first of all, we know the mass, which is 100 kilograms. M equals 100 kilograms. So we can calculate the W force, the weight. So weight equals mg. M is 100 kilograms times 9.80 meters per second square. Okay, calculator time, and this will give us, or we can do it even in our head because it's pretty simple, 980 newtons. There you go. So we have our first force that we have here in the free body diagram, and that's our W. Okay, now we're gonna proceed and calculate these two. First, we're gonna take a look at Newton's law, F equals ma, and this is a static situation, so therefore no acceleration, so the forces will be equal. The sum of the forces will be equal. We're gonna be dealing with more than one force, so we're gonna do sum of the forces. So let's look at some of the forces in the x direction, which will be equal to 0, and then some of the forces in the y direction, which will be 0. Now let's take a look at our free body diagram. FB is only in the x dimension. Here are x and y, and FB is only in the x direction, so there's no y component to it. But FA, we need to break it up into components. So we're gonna have this component, and we're gonna have this component. We're gonna call this FAX. We're gonna call this one FAY. And these are vectors, so let's put the little arrow on top of them. And now, using trigonometry, we can calculate some forces. Now that we broke these up, let's see what kind of sum of the forces in the x direction. What does that mean? Add up all the forces that are acting in the x direction. We have FAX is going this way, so we're going to use it with a negative. So negative FAX, and we have FB this way, which is plus FB equals 0. Now let's take a look in the y direction. Y direction, we have FAY going up, so we're gonna write it with a positive, and we have W going down, so that's minus W, and the sum is equal to 0. From trigonometry we know that since this is 60, we're gonna have this one as well, 60 degrees. Now we're gonna break up our FAX and FAY in a way that we're gonna have FA in it. Okay, let's see if we can substitute these out. FB should be FBX because it's in x direction, but FB equals FBX. There's no y, so we're not gonna substitute anything out of there. So let's worry about FAX. Here it's going to be minus FA times cosine 60 degrees plus FB, which we're not changing, equals 0. Let's go over here. FAY. Let's do the same process as here. Here we're going to have FA times, and since it's opposite of the angle, we're going to have sine 60 minus W, or we could say mg, but we already calculated, so we can go ahead and plug in as W. Now I'm gonna continue to work on this one, because from here we have this value, we have this value, so we can go ahead and find FA. FA equals W goes on the other side, we divide with this one, so W sine of 60, we can go ahead and plug in. FA equals W is right here, we calculate it to be 980 newtons, and sine 60, we can enter it in the calculator, and we're gonna get a value of 1132 newtons, 1132 newtons. This is our FA. So now we come back here, we have our FA, we just calculated, cosine we know, we can calculate FB. So FB, that's gonna go on the other side, becomes positive, divided by cosine. Actually, let's see, no, that's all, we don't have to divide. FB equals FA times cosine 60. There you go, we just move it to the other side and we're ready to go. FB equals FA from here, 1132 newtons times cosine of 60. Now with calculator we can go ahead and find the value, which is 568 newtons. There you go, we have the two forces. Now to finish off, let's calculate. Now let's take a look at what kind of a weight does this cable or rope needs to be able to hold in order for us to be able to use it. So our biggest force that's gonna be applied on this rope is right here, FA. So we're gonna take FA. Let me zoom in for a little bit. Let's take FA divided by gravity, which is 1132 newtons divided by 9.80 meters per second square, and this will give us 115.5 kilograms. So the cable or the rope that we're gonna be using here needs to be able to hold a weight that's bigger than 115.5 kilograms in order to be safe and make sure it doesn't fall on our heads.